Flack math! Give me some math and I'll give you some flack. Flack math!
Lesson 55 is complex fractions, which is not complex. The reason why they call it complex is because they're just fractions inside of fractions. So fractions are just division problems. So our homework is just going to be 55, 56, 58. Okay? They're just division problems. So for example, if I have A over B over C over D, how do you divide fractions? Copy, dot, flop. So which one are we copying? A over B. So A over B, copy, dot, the division symbol, and then we're flopping the C over D. Right? So now, when you multiply fractions, so because division and subtraction, remember we've talked about this, division and subtraction are dumb, so try to avoid it as much as you can. So turn your division problems into multiplication problems in algebra, and then turn your subtraction problems into addition problems. If it's confusing to you, then do that. It's a lot easier, okay? So when you multiply fractions, you can either cross reduce, so you're looking for similar factors that you can cancel, right? Anything cross cancel? Nope. So you just multiply the top. So you just get AD over BC and you're done. That's nice, right? So it doesn't feel like we did math. And a lot of times in algebra, it doesn't feel like we actually calculate anything. Calculate, when I think of calculate, I think of calculator. So you wouldn't put this in on your calculator, right? Because we don't need to know what A times D is because we don't know what A is and we don't know what D is. So you're just kind of squishing stuff together and rearranging stuff. Okay? So see if you can do this one. What if it's A over B divided by C? So see if you can give me an answer for this. You got an answer, Anna?
I just have A over BC.
A over BC? Okay, let's see. So I'm going to copy the top fraction. I'm going to dot the division sign, and I'm going to flop C. Well, C is not a fraction, right? So remember, when something's not a fraction, you can always throw it over 1. So how do you flop C over 1? Just 1 over C, which is A times 1 is A, B times C is BC. Good job. All right. So what Saxon does is they add this other step that in my opinion, seems a little confusing. So what they do is they want to get rid of this fraction. So how do you get rid of a fraction? You multiply by its reciprocal. You cancel it out. But whatever you do to the bottom, you do to the top. So they say, okay, well, you have to multiply by D over C to make it a 1, right? Well, let's multiply this by D over C, which is what you're doing here, which is just copy, dot, flop it. So I don't understand why they do that. Maybe they have a good reason, but this is just a division problem. So just copy, dot, flop it. Okay. All right. I'm going to do 2 more examples, and I'm going to try to make it difficult, but it's difficult to make this difficult. Okay. So let's do a couple more examples here. Come over here, 1 over C over 1 over B. So copy, dot, flop that. And what do you get? Can you do it in your head? Nathan?
B over C.
B over C. Right? So this is flopping to B over 1, and you're going to copy dot flop it. So B over C. All right, so probably as the most difficult it will get will be something like this. So this is example 4. I'm skipping example 3 because I feel like you guys get it. Okay, so let's try this. So this is about as complicated as it will get for now. And then later we'll have complex fractions. So fractions within fractions within fractions. Kind of like Inception. A dream within a dream within a dream. So this one might be a little bit difficult to do in your head, but it's definitely possible. Anyone have an answer? Yeah. You have one, Audrey?
I have a squared plus ax over bx.
A squared, I think you meant to say a squared plus ax. Because, so we're going to flop
Yeah, that's what
flop
I said.
that, a plus x over b. Okay, so then you can distribute this. So basically you end up with this all over bx or xb. So far so good, does that make sense? Okay, and then we don't like parentheses, we like it simplified, so you can multiply that out, a squared plus ax all over bx. Now, good job not canceling these. Why can't you cancel these x's? You remember, Nathan?
Because it's being added.
Yeah. Oh, your voice changed. That was weird. Okay. Yeah, because this is a plus x divided by x. So adding x and then dividing by x does not cancel it. If this was just ax and then x, then yeah, because that's being multiplied by something. And so x would be a factor. X is not a factor. The only thing you can cancel are factors. So x is not a factor here. All right. Okay. That's 55. You guys feel okay with 55? Good. Let's move on to 56. All right, so we're going to do finite. What's finite mean? What's finite mean? That's what it said. What's finite mean? What does it mean to be finite?
Small,
Not necessarily.
precise.
Precise? Okay. Well, what is it not?
Drop.
A rock? I think a rock is finite. What is it the opposite of? Let's put an in and the word in front of it. What's that word? Infinite. So we don't say infinite. We say finite and infinite or infinite sets. Okay, so infinite sets go on forever, like counting numbers, right? We got 1, 2, 3, 4, 5. It doesn't stop. But finite sets could be like the counting numbers between 1 and 100, right? There's like there's 99 counting numbers between 1 and 100. All right. So that would be an example of a finite. There's an ending to it, right? It stops at some point. Okay. So when you build finite sets, if you have a bunch of numbers here, let's see here, we got numbers 0, 0, 0, 1, 1, 1, 1, 1, 2, 2, 2, 1, 1, 1, 0, 0. You could say that these numbers, B represents the numbers 0, 1, and 2. Okay? So even you don't have to put how many zeros? 6 zeros and 8 ones and 3 twos in that set. This set just represents the numbers that are on the board. Okay? So for example, if we said the ages in this room, there would probably only be two or three numbers in the set, even though there's 7 of us in this room, right? So the set just represents the type of numbers that are, basically declares the numbers that are represented, not how many times they're represented, just what numbers are represented. Okay? And then we say B is called the set. So these guys, remember, these are braces. And these guys, these are just called members. And sometimes we call them elements of the set. Okay? So if I was just given the set B, I wouldn't say B is the set of number 0, 1, and 2. Well, it says B consists of 0 or any number of zeros, 1 or any number of ones, 2 or any number of twos. So we don't know how many zeros, ones, and twos we're talking about by just looking at that set. Does that make sense? Okay. All right. So you're going to have this on your test, one of your tests coming up, but then you probably have this in your homework. So set K is 1, 0, 2, 1, 0, 5, 7, 4, 5, 7. So I want you to represent set K in set notation. So this is called set notation. So give me the set K in set notation. So K equals brace. What's in the set? And then another brace. Okay, everyone have this so far? Everyone have that so far? Okay, so it's not totally necessary to put them in order, but put them in order because that'll help you sleep better at night. Okay, so what number should I put first? 0. All right, well, there's 2 zeros. Should I put another 0? No. What's next? 1. What's next? 2s. Any 3s? No. So let's skip to 4. Any 6s? Anything after 7? All right. Is that what you guys got? Good. Okay. So here's the other. I'm gonna teach you a couple new symbols. So I could say that 1 is a member of K. So that little epsilon, that little E, that fun little E there, that's the way I remember it is another word for member. What's another word for member? Element. So that's an E. So 1 is an element of K. Okay? I could also say that 3 is not an element of K, or not a member of K. So far, so good? Pretty easy? So you're going to have true or false questions on one of your tests coming up. And they're going to look like this, and you just have to say true or false. That's pretty doable, right? Okay. So let's see. Yeah, let me just erase this. And so this is probably exactly what your future test will look like. This next example. So it's not going to be the. Oh, it could be the next test, I guess. Yeah, it'll be the next test. Okay, and then it's going to say this. So true or false? Is A true or false? True. 5 is indeed an element of A. It's inside of that. So true. What about B? Is 4 an element of B? Oh, C. So is 4 an element of C? Nope. It's not in there. What about C? 5 and then that symbol B. Is that true or false? True, because this symbol means 5 is not in B. Well, here's what's in B, and 5's not in there. So this statement is true. Okay? So some of you who are like me, who might have dyslexia, dysgraphia, this is sometimes a struggle because you're like, wait a minute. I said true to this false statement. What? So it kind of messes with your head a little bit. So just say it out loud if you need to. 5 is not inside of B. All right. Did I just sin? Nope. I'm good. All right. So I didn't lie. That's true. Okay. So sometimes I know it's silly. You just have to say it out loud. When we get into subsets and things like that, it's going to be it's going to add a little bit of trickiness to us who are sometimes can't tell what's forward and backward. Okay. All right. The last part of this lesson is just rearranging equations. We already did some of this, but if we rearrange a linear equation, it's a lot easier to graph. Okay, because most of the time when you're given a linear equation, it's good to know, or they might ask you to graph the equation. Okay, and so the way we did graphing is we started this little XY chart, and then we pick X's and Y's that would make the equation true, right? Well, if we had something like this, 3x plus 2y equals 4. Can you think of X's and Y's that would work? It's a little bit difficult, isn't it? So can you think of 1? An XY combination, what X would and Y would have to be for that equation to be true? Can you think of 1? Nathan?
X is 1 and Y is 1/2.
Yeah, so it's kind of, you get a fraction, right? So if X is 1, then Y would be 1/2. If X was 0, then Y could be 2, though. So if X was 0, remember that cancels that out. So then you get 2Y equals 4. Oh, Y is just 2. It's 2 times 2 is 4. Okay, you could do like a 2 and negative 1, because if X is 2, that would bring this up to 6. Plus negative 2 would get you 4. So if Y is negative 1, but that's a little bit too much math in your head, right? So what I'm going to suggest is to get Y by itself. So how do you get Y by itself? Let's rearrange this equation so Y is by itself. We did this on the last test. How do we get Y by itself? We have to get rid of two things.
It's variable, it's coefficient.
Yep, so you need to get, this is the variable we want to get by itself, so we want to eventually get rid of that, but we have to get rid of this whole term. How do you get rid of that whole term? We subtract it, right? Well, the shortcut to subtracting is to just put this over there. So when you do that, it becomes a negative 3x. So we get 2y equals negative 3x plus the 4 that's already over there. Now, the reason I do it like this is because we're going to show you a shortcut to graphing equations, and the x will need to be first. But you could have just subtracted 3x from both sides, because then you'd have 4 minus 3x, right? Well, 4 minus 3x is the same thing as negative 3x plus 4, right? It's 4, like, think about it. 4 minus 3 is the same thing as negative 3 plus 4. That works, okay? So now, but we're not by itself, so what do we have to do now? How do we get rid of that 2? Divide it, okay? So y equals negative 3x plus 4 all over 2, right? Okay, so we could do this separately. So negative 3x over 2 plus 2, right? If you divide both of them by 2. Now this is something a couple of you messed up on your last test, so pay attention to this. So when you divide a whole side by 2, you have to divide each thing. Or this, when you divide this binomial by 2, make sure you're looking up here, paying attention. Then everything gets divided by 2. So you can create 2 separate division problems. And then this one you can simplify to just 2. But this one you have to leave the same. Okay, now you say, why is this easier? Well, it is easier. It's still easier because now when I plug in my x's, I know now that I have to pick an even number, because that will make that easy. So if I pick like 1, I'll get negative 3 times 1. So negative 3 over 2, that's a fraction. It's okay to have a fraction. There's nothing wrong with that. But let's pick an even number. Let's say x is 4. Negative 3 times 4 is negative 12 divided by 2 is negative 6. Plus 2 is negative 4. So you get 4 and negative 4. Okay? So this, when you have a fraction in your x term, then multiply by something that will cancel that. So if it's something over 2, make it even. If it's something over 3, make sure it's a multiple of 3. You don't have to. You can live with fractions if you want to. But it's easier to do it that way. Now watch this. Now this is the way you do it when you don't know the shortcut that I'm going to teach you next week. Okay? So you can always do it this way. And I think most of you feel comfortable with doing it this way, just trying to figure out x's and y's that will make that true. And if you have that, then you can graph it. So how do you graph 1, 1/2? So describe to me how to graph 1, 1/2.
Put it in the middle of the 0 and 1 on the y scale, and put it on the 1 of x.
Yep. So which one's the x? Yep. So we go over 1. So if it's listed your x and then your y, then you go left or right first, this much. So positive 1 means 1 right. And then positive 1/2 in the up or down thing means up 1/2. So this would be about right there. Okay? How do you graph 0, 2? The zeros are always the difficult ones for some reason, especially for us that have backwards thinking issues.
Leilani, go to 2.
You put it on 2 of y.
Yep, because you go left or right 0. So you don't go left or right. You just go up 2. All right, 2, negative 1. So right 2, down 1. 4, negative 4. So right 4, down 4. And look what we got. We got a nice line there, kind of. Okay. So again, you can always check to make sure you're doing this right by seeing if your line is straight. If your line's not straight, then you either calculated a coordinate wrong or you plotted those points wrong. Okay. Okay, let's try two more. One more, and then we'll be done. So here is example 6 in this lesson. So I want you to just graph on your paper y minus x equals 0. This is too easy. Like you don't even have to rearrange it, but let's rearrange it first and then see what it looks like on the graph. All right, so with your pencil, I want you to show me what the line looks like. All right, everybody got them right. Micah, what's your line look like?
I got the answer, but I didn't have the pencil.
Oh, got it. Okay, let's look at it. Here we go. So I'm going to rearrange this. Just if you put the x over on the other side, it just becomes a positive x, right? So, or you could just add x to both sides, doesn't matter. So y equals x. So when does y equal x? Any number, 1, 1, 2, 2, 3, 3, 4, 4. How do you graph those? Over 1, up 1, over 2, up 2, over 3, up 3, over 4, up 4. So that's what your graph looks like. Okay? You guys feel good about this? Now, you don't have to rearrange it if you don't want to for now. You could still try to figure out, maybe this was easier for you to figure out the x and y combinations in this form. But this is nice because you can just throw in an x and it will spit out a y. Okay? So this is kind of like those nuggetizers where you put in something and you know what to expect. This does all the work for you. You don't have to try to do math in your head like you would here. You can just put it into this and it spits out the work for you. Okay? Any questions? You guys good? All right, awesome.